Hello, this is Mr. King,
This is Mr. Brace.
and today we're going to talk about the ACT Science portion a little bit with a focus on data representation. Now, since this is the first EPASS Wednesday for science, we wanted to give just a brief overview of the science section of the ACT. So there are a total of 35 questions on the ACT, the science section, and you have 40 minutes to complete it. Now, this is the last section that you'll take, which is important because as you go on, you'll experience some fatigue because you've been taking the test for like 3 hours at this point. And so historically, for a lot of students, the science portion is really where they struggle. And the interesting part is the science section is not really content-based. I mean, it uses science content, but you don't have to know the science content for that portion of the test. In fact, most of the content they use is actually, graduate level stuff that they're talking about. And so, really it focuses on the skills of how do we, they're kind of three big skills. The first is data representation. How do we represent data which might be collected in an experiment? And then there's research summary, where we compare, the scientific method. We compare different experiments to see what we can learn in that comparison. And the last kind of idea is, how do we resolve conflicting ideas in science? And so those kind of concepts are tested in the three big passages. And you can see here on the screen we have data representation, which will be 5 or 6 questions per passage. That's the one we're going to focus on today, so we'll come back to that. The next one is research summary. Now this is where, again, it's 5 or 6 questions per passage, and this is where you're going to really be comparing different experiments. So what happened in experiment 1 versus experiment 2? What did they change? What did they keep the same? It'll even test you a little bit on those scientific vocabulary for the scientific method, like what's the control, what's the variables, those sort of ideas. And last is conflicting viewpoints, which I found personally to be hardest, and that's where you have 2 different ideas presented to you by different scientists, and you have to sort of figure out what pieces of evidence support which viewpoint. And those can be really hard because a lot of times you might be even arguing for or finding evidence for a theory that sounds really strange, or something you don't really think is true, or something you may know is not true, but that's not the point. The point is, can you pick out the facts and evidence that support those ideas? But like I said, we're going to focus on data representation passages, and I'll pull one up in just a moment. So this is an example from a ACT passage of a data representation. And what makes data representation considered to be one of the easier sections a lot of times is that a lot of times it really is just looking up information in a table. Can you identify the correct table, and then can you find it? So you may be looking at tables in a data representation passage. You might be looking at graphs. Now this is a graph within the question, but still you could see some kind of graph like this. And so a lot of times you'll be looking at data represented in either a graph or a table for the most part. You can on occasion get some weird like pictogram sort of things, but by and large most of it is going to be either a table or a graph. And sometimes you may be asked to just look up direct information. Like I could come up with a question here that might be, what was the concentration at 40 degrees Celsius? Well, okay, I look up 40 degrees and I try to look up, although there's no scale over here, but that's what I would do. So it's look up, or look up in here. But the other thing that you have to do that sometimes people struggle more with is interpreting data. And you might have, like, instead of this being a nice even, see how it's a line or a curved line here? Instead, it could be like you would have a little scatter plot, like little dots, and you'd have to figure out information in between, and you will see an example of that later, which is something that sometimes students struggle with. Mr. Brace is going to talk about this table here and talk about kind of how to break down a table. What are some key tips?
So it's really quite simple. When you look at tables like this, initially they may look very intimidating, but if you start looking at the columns and the rows, it's really quite simple. First of all, you've got table 1. A lot of times that will relate to possibly experiment 1. You just have to pay attention to those details. The next row, you have your concentration of solute. That's really basically talking about your chemical and the mixture within water. Your third row, now it starts to break down into a couple of different pieces. The first column is going to be temperature, and you can see very simply, temperature is increasing as you travel down the table. And then the next big chunk of the table is very simply every column is a different chemical, and then you can see changes within that chemical as the temperature does increase. So this is one of the more complicated tables. Some are very simple, some might be more complex. Hopefully with the tables we look at today, they will be moderately challenging for you.
As Mr. Bryce was saying, just looking at the columns, looking at what units they're there, will help you a long way. You'll notice that a lot of times there's also introductory text to these tables and passages. You really should read that. There's different strategies on whether you read it at the beginning or read it when you need to, but I do like to read it at the beginning just because it gives you some idea. And again, sometimes it might be pretty advanced stuff, and you don't have to know you don't have to know what NaNO3 stands for. It's not required in order to do this. You just need to know, okay, it's some kind of chemical. That's good enough to get through here. So you can read through this, and it'll tell you what you can read there.
Really, it's just common sense. Are you pressed for time? Are you running out of time? If you're not, yeah, take time, read through the passage, and make sure you've got a thorough understanding. If you've got 10 minutes left, maybe you only start seeking information when it comes down to it.
So we're going to look at a few examples in this passage. Again, just another ACT science passage. We're not going to read through this part, although some of this information will come in handy in a little bit, but we're just going to show you kind of what we would do if we're going to think out loud, kind of like if we're trying to take the ACT. And so we'll start question 25. According to figure 1, so immediately looking at this, notice this is called figure 1. There's another one further down called, as you probably could guess, figure 2, but this question only requires figure 1. So according to figure 1, after 2 hours at 403 Kelvin. So, and this is what I'm doing immediately. Even before I get to the end of the question, me personally, I'm already looking at 403 Kelvin. That's the little circle, the hollow little circles. Okay, so it's this line is what we're talking about. And it says after 2 hours. So I can already kind of, now again, remember you have to, here they kind of drew the line for you, but I'm here. It's not an exact point, but I'm about here. So according to figure 1, after 2 hours at 403 Kelvin, the percentage of La converted was closest to which of the following? So this is, again, pretty easy. I just need to read up on here. Well, it's clearly about halfway between 60 and 40. And remember, this is something I never see people do enough, really. You can write on your test. So you can draw any lines you want. You can draw a straight line across. You do not have to just eyeball it. Feel free to write in your test. But hopefully, as you can see, this is pretty close to 50%.
Question number 26, according to figure 1, at 423 Kelvin. So 423 Kelvin is going to be the hollow triangle. The greatest percentage of conversion occurred during which of the following time intervals? So when you look at these hollow triangles, they're really asking, where do you see the biggest change? And when we look at this, we see there's a huge change from 0 to 2. It goes basically from around 0 all the way up to maybe a little bit more than 60%. So that's why our answer in this case is going to be 0 to 2 hours.
27, which of the following was held constant in each of the experiments? And this is where you do have to read this information beforehand to try to figure out. If you notice in this thing here, it says each acid was mixed with an RUC catalyst. Again, I'll be honest, I know what a catalyst is, kind of, but I don't know what RUC means. It doesn't matter. That's the big point. Don't let these words get you down. Don't let them, again, this is the last part of the ACT. Don't get fatigued and just give up. It doesn't matter. Just know that, okay, they're given the same, it looks like they're given the same catalyst. And I can see here that it says, along with 50 milliliter aqueous solution, along with 5% Ru per C catalyst. Exact same thing out here, along with a 5% Ru per C catalyst. So the correct answer here is the amount of catalyst used, A.
Number 28. Based on data in tables 1 and 2, which of the following best describes the results of the experiments? As conversion time increased, the percent of acid converted. Now you're going to have to probably read through each of these or analyze your charts a little bit more closely. So we can look at the charts and we don't see any decrease whatsoever. So that's a nice way to eliminate a couple of these options. F and H can both be eliminated. So we can look at G, increased at some temperatures only until conversion stopped, so that's G, and then J increased at all temperatures until conversion stopped. So we know they're all increasing, so that leaves us with J. It's no sum, it's all of them. They're always increasing. So J is going to be your answer.
29. A chemist claimed that the propionic acid conversion rate at 403 Kelvin dramatically increases between 8 and 12 hours. Do the results of the experiment support this claim? So if you look down here, this is talking about propionic acid, which is the Pa on the side here. So we're looking at this one. Be careful not to look here, but look at this one. So Pa between 8 and 12 for a 403 Kelvin. So 403 Kelvin is the solid squares, and it looks like the reaction kind of stops after 7 hours. That's what this implies. Or at almost nearly 8 hours, it kind of stops. So we would say on this that it doesn't seem to support it. And then so we automatically know it's either A or B. The difference here is this one says conversion stops after 8 hours. This one says nearly 100% has been converted after 8 hours, which clearly, I mean, we're less than 40% converted. So A is the correct answer.
Number 30. Based on the results of experiment 2, assuming that conversion of Pa8 at 423 Kelvin continued until it reached 100%, one would predict that 100% of the Pa would be converted during which of the following time intervals? So, if we are looking at this section, what's our temperature? 423. That's what we're looking at. Page 423 is the hollow triangles. We're basically projecting the triangles out beyond where they are. We're extrapolating. We're going beyond what the graph allows or shows us. And this goes back to what Mr. King talked about. Feel free to write on your tests. They're yours. No one else is going to use them. So a lot of times what I will do is I will extend this line out. I will draw a line back to where it currently is. You can draw a bracket at the bottom of the section, and you can measure out approximately, eyeball it, where you think 14 would be. And then you can draw your line up to the top, you can extend the line out, and you can start thinking about what are some of your possible answers. And based on some of those projections that we have, we would say that it is going to be between 12 to 14 hours.
And I do really think there is a typo on this that says greater than 12 hours. I think they meant to say greater than 14 hours because it just doesn't make any sense to me. So that's kind of, again, some of the thinking that we used. We've got a passage that you all are going to try out, and you can test it for yourselves. Now, in order to control kind of the timing of it, we'll ask the academic time teacher after they pass this out to not let anybody start until you all start at the same time, and you'll get 5 minutes, and there will be a link to the next video that you'll start after you all take 5 minutes to try to answer them on your own. So again, hopefully you can use some of the ideas and skills that we talked about here in answering these on your own, and we will go over the answers after you attempt it.